How's it going, everybody? And welcome back to our NSX-T series. In this video, I'm going to be giving you guys a high-level overview of the edge nodes and the edge cluster that we're going to be deploying in the next video. The idea here with the edge node is to provide a connection point between the logical for the NSX environment. So we have ESXi hosts deployed, NSX-T installed on those hosts, overlay segments deployed. We need some way to get the VMs that are attached to the overlay segment port groups out to the outside world, right? And the way you do that is through the edge node. So this is really designed for the services and capabilities that you can't deploy to a host directly. So let me go ahead and we're going to jump over here to my documentation. I'm going to get out of the way. I'm going to zoom in on this, and we're going to talk a little bit about the details. And if you guys have any I'm going to try to answer all the questions that you may have. And then if you guys have any additional questions, throw it in the comment section below, and I will do my best to try to answer those details. I'll cover through, the capabilities here real quick. So the edge node itself is a services appliance with pools of activity dedicated to running network and security services that cannot be distributed to the hypervisors. It provides the connectivity to the physical infrastructure, and so whenever you enable any one of the multiple services that you can do, or an external link, or external interface is defined on the tier 0 gateway, an SR is instantiated on the edge node. A SR is a service router, and the service router is going to be doing all the heavy lifting. So think of the edge node as nothing more than a virtual machine that doesn't have anything going on inside of it. Think of just a VM. It's an empty container. So if you want to do things with it, you will selectively go into NSX Manager and turn services on, and NSX Manager pushes those services to the edge node, because you're going to associate all the services that you want to do to the edge node when you're deploying whatever it is you want to roll out. So that's basically what's going to end up happening. The edge node is also a transport node, just like the compute nodes, but it can connect to more than one transport zone. So it's a specific edge node can be connected to just one overlay transport zone. It can be connected to more than one VLAN transport zones for north-south connectivity. So typically speaking, you're going to have one overlay transport zone, normally speaking, and that's how I've always deployed it. One overlay transport zone, just the overlay TZ. And you can see when we were deploying that I created a second VLAN back transport zone. Not one that was connecting our VMs that are connected to the VLAN back segment that was pushed from NSX Manager, but another one that's going to be used to connect the edge VM to the outside world. So what is the outside world? You might be asking that question. The outside world, in a realistic perspective, will be from these interfaces right here, these trunk uplinks of VMNIC 5 and VMNIC 6. Think of those as actual physical connections going up to a top of rack switch, like a Nexus 9K or an Arista box or a Dell switch or whatever it might be. That's what you're connecting to. This is going to connect the virtual to the physical. In this case here, the virtual, the CSR 1000Vs are simulating top of rack devices, but realistically, they in the real world deployment, these would be physical hardware, some type of data center class switch. So that's what that means. So you have two different transport zones on the edge overlay, and that's going to be for traffic originating from a VM, requiring reachability to external devices or networks, typically for north-south traffic and things like that. Then you have the VLAN, which is going to be used to connect to the outside world. So some specifics about each one: traffic originating from a VM in NSX requiring reachability to external devices or networks. This is typically defined as north-south traffic. VMs may also require centralized services like NAT or load balancing, also taken care of on the edge. To provide north-south reachability and use centralized services, overlay traffic is sent from compute nodes to edge nodes. Edge nodes need to be configured with single overlay transport zone so it can encapsulate overlay traffic to and from the compute nodes. Hence, why we use one overlay TZ. However, on the edge node, like we've already mentioned, physical network connectivity, VLAN transport zones provide external or north-south connectivity to the physical infrastructure. One or more VLAN TZs can be mapped to an edge node. Each edge nodes can have one or more NVDSs to provide needed connectivity, so you don't have to tie everything to one NVDS switch. Each NVDS on the edge node uses an uplink profile, which can use the same or unique per NVDS. So if you have a specific mapping that you want to use, you can do that. Teaming policy defined in the uplink, and this uplink defines how the NVDS balances traffic across its uplinks. So again, the uplink profile is going to dictate, is it failover? So you're going to have an active NIC and a standby NIC, and then if active fails, standby NIC takes over, or are you going to load balance across the two? An uplink can be turned into individual physical NICs or a link aggregation group. When a edge node is deployed as a vCPUs are allocated to the Linux IP stack and the data plane development kit, or the DPDK. Now, you can do multiple TEP support on an edge node. So edge nodes support multiple overlay tunnels, multiple multi-TEP to load balance overlay traffic for overlay segment logical switches, supported in both the edge and the bare metal. Each overlay segment logical switch is pinned to a specific tunnel endpoint IP. Each TEP uses a different uplink. So TEP 1 uses uplink 1, which is mapped to physical NIC 1. TEP 2 uses uplink 2 and mapped to physical NIC 2. Now, I want to take a moment here. When you look in NSX Manager, you're going to see two IP addresses, because you're going to have, just like the edge node, the transport nodes for our compute devices or compute hosts, they are also going to have two interfaces tied to the NVDS. That's why we see two TEP IPs. Now, you're going to load balance traffic across both, but you're going to source from one. So allows for load balancing overlay traffic, simplifies NVDS design on the edge. Prerequisites that must be met: TEP configuration must be done on one NVDS. All TEPs must use same transport VLAN for overlay traffic, which we've already got that done. Now that's on the edge, specifically for the edge. That's why we created the edge node pool and the IP address pool and created that, and it's got its own dedicated VLAN for the overlay, which is 171. All TEP IPs must be the same subnet and use the same gateway. You'll see when we go to actually roll out logical connectivity and map the overlay segments to the edge node, you'll notice that there will be tunnels built from the 172.31.170 subnet to the 172.31.171 subnet. And it's going to be using the CSR 1000Vs to provide that inter-segment communication, that inter-VLAN routing, and all that good stuff that goes along with it. So multi-TEP support for the edge removes critical topology restriction with bare metal straight through lag, allows the use of multiple physical NICs for the overlay and bare metal and VM form factor. An edge VM supporting multiple TEPs can have two uplinks from the same NVDS, allowing utilization of both physical NICs, basically giving you efficient load balancing. You can do teaming policies on there, if you will, normalization of NVDS configuration. All form factors of edge and deployments use single NVDS along with the host. Single teaming policy, single policy for north-south peering, all that good stuff that goes along with it. Now, there is a bare metal edge that you can deploy. I've never done it. I have no idea how that process works, other than a little bit of documentation that I jotted down about how that comes into play. But you can do this on a physical box. We will be deploying through the the virtual node, so the VM can support via the OVA, OVF, or the ISO file. Only supported on ESXi hosts. So when we go through and do this, we're going to go through and deploy through NSX Manager, and we're going to deploy through vCenter Server. So there's going to be 4 network adapters mapped to each edge node, and you're going to have, the first one is going to be ETH0, which is reserved for management, and FastPath, FP, is going to be ETH 0 through 1, or sorry, 0 through 2. And you're going to have, I'm going to use the first 2, and that will be 0 and 1, and we'll validate which ones are which. So allocated for external connectivity to the top of rack switches and for NSX-T overlay tunneling. Complete flexibility in assigning fast path interfaces for overlay or external connectivity. So you can do this. You can do fast path 0 could be assigned for overlay traffic, and you can do fast path 1 and 2 could be used for external traffic. You can do either one. I have chosen to do 0 and 1 to do both. It just makes things a whole lot simpler. There is a default teaming policy per NVDS that defines how the NVDS will balance traffic across its uplinks. The default policy can be overridden at any point in time. Multiple NVDSs per edge VM design. I'm only using one, but you could use multiple if you would like. Now there is a breakdown in the design guide that I wrote down, but I'm not going to spend a ton of time breaking into that specific variation. That's pretty much what you need to be aware of when it comes down to how this all comes together. The deployment is pretty straightforward. I'm going to walk you guys through that in the next video and how we actually roll that out. But at the end of the day, the capabilities are pretty straightforward. It's just an empty virtual machine. We're going to deploy that via NSX Manager and vCenter Server, and then I'm going to show you guys how to bring the OVF deployment through vCenter online. Because when you do it and it comes online, there's a join command that you're going to have to enter that basically joins it to NSX Manager, but then you have to configure NSX. So you're going to have to do the transport zones, you're going to have to give it the TEP IP address pool, all that type of stuff, and then determine which interfaces you're going to map, because you can only do 2 when you go to set it up, because that's how many NICs you're going to have available to you. So that's basically what you're going to have to end up working with. So that's basically essentially that's the basics. So as we go through and get all this other stuff set up, you'll see that it's pretty straightforward. And once we have everything deployed and everything's good to go, then after that, once the edge nodes are deployed, we're going to join into an edge cluster. And you can deploy the minimum of 1 edge node and then deploy it to a cluster. Once you've done that, then you can go ahead and start connecting because you have to call the cluster in certain parts of your configuration. You can't just call the edge node itself. So you call the cluster that includes the nodes themselves, and then you can start working with different things. So when we go to the overlay segments and start mapping a segment to a connected gateway, so we'll have to deploy like a tier 0 gateway to show you both a single tier routing architecture with just a tier 0 gateway, and then a tier 1 gateway to do a multi-tier routing architecture. When you do that, then you'll be able to go a step further and see how the inter-segment routing will come into play, which we'll be taking in a following video. But that, ladies and gentlemen, is the basics to what you need to know about that connectivity and how it all goes together. Now, since we're going to be deploying 2 edge nodes, you're going to end up seeing, once the cluster comes online and all the edge nodes are squared away and successfully deployed, you're going to see that the edge nodes are going to form 2 tunnels to each other. So they'll be talking back and forth between each other and all that good stuff that goes along with that. With that being said, ladies and gentlemen, I want to thank you guys for stopping by and hanging out with me, and I'll catch all of you guys in the following video.